So, this is going to be a short lecture on the concept of internal validity. Internal validity refers to how well an experiment is done, particularly whether or not there were confounding variables involved with that study. Confounding variables are any aspect that may have an effect on the outcome of the study and have an effect within the control and experimental groups. So, internal validity can be further broken down into strong and weak internal validity. So, strong internal validity occurs when a cause and effect relationship can be established. That's typically going to be with more experimental designs. And that is because there are little confounding variables involved in the study. There's also weak internal validity, which occurs when multiple confounding variables are involved that ultimately may have an effect on the outcome of the data. And you're going to see that more with observational designs than with experimental designs. So here's just two photos that kind of have to do with internal validity. On the left, you say your program works, but why should I believe you? Because I have evidence. And then on the right, there's a flaw in your experimental design, all the mice or Scorpios, and that's referring to the threat to internal validity that is sampling, because in this case, clearly their sample population is of the wrong population. So the threat to internal validity covered here is going to be selection bias. Selection bias can occur when experimenters choose participants, which are put into each group, the experimental and the control group. The best ways to reduce the chance of selection bias are random sampling and random assignment, because it takes any bias or any potential confounding variables out of the situation. It's a threat to internal validity because the control and experimental groups may not be equal and therefore cannot give a valid comparison to each other. So an example of selection bias would be, in this case, we have a study in which they're studying the effects of a blood pressure management drug in men. In this case, the researcher chooses which participants in the study are put into each group, therefore not using random sampling or assignment. And in the control group, he selects only men over the age of 65, whereas for the experimental group, he selects only men under the age of 65. So that's a huge problem because those two different groups of men have different health needs, and we're only studying them in their respective populations, which is an issue because you can't get a valid look at how the drug is working in all of the target population.